Hello and welcome to the second video on the introduction to Laplace transformation. So in the very first video, I said we have 7 tables of standard values in the Laplace transformation. In the first video, we talked about 3, and in this video, we are going to be talking about 2 tables of standard values, which will be aiding us as we go deeper into Laplace transformation. Now, the very fourth table of standard value is the Laplace of cosine function. Laplace of cosine function. So let's say we are given a function f of t to be equal to cos at, where a is a constant. Okay, we can simply call a to be 5, a constant, so you can simply say cos 5t. all right, and we're asked to find the Laplace of this function. Now let's take our formula. The Laplace transformation of any function f of t, okay, is given as integral from 0 to infinity of that function f of t multiplied by exponential minus st dt. And I said in the first video that since we have two functions multiplying one another under the integral sign, it means we are going to be employing integration by parts, which is the product integration, to evaluate Laplace transformation. And what is our integration by parts? Integral of u dv is equal to uv minus integral of v du. This is simply this formula for integration by parts. And I say u always is the given function f of t, and dv in this case becomes the function of the Laplace itself. All right, so that means the Laplace of, now the function we're talking about is what? Cos at, which you actually call cos 5t. So we are simply saying let a be equal to 5. So this is cos 5t. We are using an actual number now. It's simply integral from 0 to infinity. In place of f of t is cos 5t times exponential to the power of minus st multiplied by dt. Now we have this product of two functions, which means we are going to employ integration by parts. And I said always consider u to be what? The given function, which is cos 5t. all right, so u is equal to cos 5t, and always consider dv to be what? Exponential minus st times dt. Okay, so dv is simply what? The whole of this, the Laplace function itself. Now from the formula, we need to find du and we need to find v. How do we get du? Simply by what? Differentiating u. So we obtain du. Now u is cos 5t. To differentiate a trigonometric function, I've always said in my calculus series that to differentiate a trig function, you differentiate the angle, use the value you obtain to multiply by the derivative of the trig function itself. In this case, the angle here is what? 5t. If I differentiate 5t, I will simply have what? 5. And then the trig function itself is cos. If I differentiate cos, I will simply have minus sine. So you use 5 to multiply by what? Minus sine. This will give me minus 5 sine. Then put in what? The angle 5t. That becomes the derivative of what? This function. So we simply have du to be what? Minus 5 sine 5t. But since I differentiated u with respect to t, always append times dt over here. And then to obtain v, okay, to obtain v, we simply what? Integrate dv. We simply integrate dv to obtain v. That means you're integrating exponential minus st dt to obtain v. All right, so by so doing, we are going to find that v is equal to integrate an exponential function. I've also explained this in the first video. Simply differentiate the power of the exponential function and divide the exponential function by this derivative. It gives you the integral. The power of that exponential function is what? Minus st. That's the power. From here, you have minus st to be the power. If I differentiate minus st, I will be left with what? Minus s. So the integral of that value is simply what? Use this value or this derivative to what? Divide exponential minus st. So you have exponential minus st all over minus s. This gives you what? The integral of that function. All right, so v is simply what? Okay, so if I push this minus sign up, it becomes minus exponential minus st all over s. So this is now our v. Hence, integral of u dv is now equal to, let's put them now into the formula. It says u times v, and we say let u be what? Cos 5t. So you have cos 5t times v is minus exponential minus st all over s minus integral of v du. Once more, v is minus exponential minus st all over s times du, and du gave us minus sine 5t dt. So we have times minus sine minus 5 sine 5t multiplied by dt. So integral of u dv is now equal to, alright, so this gives us minus exponential minus st, we have times cos 5t all over s minus integral, okay, or minus, please observe here, minus times minus here becomes plus, s here is a constant, 5 here is also a constant, so I can pull out 5 all over s out of this integral sign. This becomes minus 5 all over s integral of, okay, rearranging this now, I have sine 5t exponential minus st times dt. Alright, so let's call this equation 1. Observe now that we still have integral of sine 5t exponential minus st dt. So which means we also need to employ the product rule towards integrate that function. So we can simply call this equation 1. Let's pick out that function individually. Let's pick out that individual function and what? Integrate it, then put it back into equation 1 to make the work easier. So we simply pull out integral of sine 5t exponential minus st dt. Let's also integrate this. Now we are still going to obey the principle of integration by parts, because that's product integration. We have two functions multiplying one another. We will still obey this. So consider always u to be equal to now sine 5t and dv to be equal to exponential minus st dt. Once more, you have to find what? Du, and you have to find v. So to find du, same thing, differentiate this function, differentiate the angle 5t, I will have 5. Differentiate sine, I will have cos. So this becomes 5 cos 5t, and since I differentiated u with respect to t, simply multiply dt to this. And again, v itself is by integrating what? Dv. And we've done this already. If we integrate that function, we are simply going to have v to be minus exponential st all over s. So this becomes minus exponential minus st all over s for v. Hence, the integral of sine 5t exponential minus st dt is now equal to, so from integration by parts, it says u times v. And what is u? U is sine 5t and v is equal to this. This is now sine 5t for u multiplied by minus exponential minus st all over s for v minus integral of what? We said v du. And again, once more, v is minus exponential minus st all over s times du. Du gave us 5 cos t, 5 cos 5t dt. So we have times 5 cos 5t multiplied by dt. Alright, so integral of sine 5t exponential minus st dt is now equal to, so rearranging this now, I will have minus exponential minus st sine 5t all over s. Please now observe, minus times minus here becomes plus. 5 over x is a constant, so they can come out, so I have plus 5 all over s integral of, okay, rearranging this a bit, I will have cos 5t exponential minus st times dt. So this is integral of sine 5t exponential minus st dt. I can simply now substitute this integral into what? Equation 1 in place of this. So substitute, Okay, substitute into equation 1. Let's put in this value now into equation 1. So from equation 1, we can do that over here. We have integral of u dv to be equal to, so let's pull out all we have in equation 1. We have minus exponential minus st cos 5t over s minus exponential minus st cos 5t all over s minus we have 5 all over s integral. So in place of that integral of sine 5t exponential minus st dt, we have the whole of this to be that integral. So we simply what? Put in this value. So we have minus exponential minus st sine 5t all over s. Okay. And we have plus 5 over s plus 5 all over s integral of exponential of cos 5t exponential minus st dt. We simply have this. So integral of u dv is now equal to minus exponential minus st cos 5t all over s. So let's expand the bracket now with 5 over s. Alright, so minus times minus is plus. So I have plus 5 times e gives us 5 exponential minus st sine 5t all over s times s here gives us x all squared. Again, minus times plus 5. So minus times plus becomes minus. 5 times 5 here gives us 25 all over s times x here gives us x squared. Integral of cos 5t exponential minus st times dt. Okay, so let's put in now all symbols and their notations. I have integral of u dv. What is u and what is dv? We said let u be equal to cos 5t and dv be equal to exponential minus st dt. We plug them back into the equation. So this becomes integral. In place of u is cos 5t. In place of dv is exponential minus st dt. So this is equal to the whole of this minus exponential minus st cos 5t all over s plus 5 exponential minus st sine 5t all over x squared minus 25 over x squared integral of cos 5t exponential minus st multiplied by dt. So we have this. All right. Now, at this point, comparing these two equations, notice that on the left-hand side, I have this integral cos 5t exponential minus st dt, and on this part of the right-hand side, I also have the same integral repeating, integral cos 5t exponential minus st dt, which is actually what we are looking for from the question. So what do we do now? Since it is what we are looking for, we bring them together, okay? Simply collecting like terms. Send this guy over to meet this one, okay? All right, so we are going to have integral of cos 5t exponential minus st dt. Now, if negative this cross over and equal to sign, the whole of this, of course, negative cross and equal to sign becomes positive. This becomes plus 25 all over x squared integral of cos 5t exponential minus st dt. And this is now equal to, we are now having this left minus exponential minus st cos 5t all over s plus 5 exponential minus st sine 5t all over s squared. Okay, once again, in order to make one of these subjects, we have to factor out first. So integral of cos 5t exponential minus st dt is common between the two. You factor. So you have integral of cos 5t exponential minus st dt, which is common between 1 plus 25 all over x squared. So if you expand this bracket, of course, you'll get back this. So this is equal to the whole of this minus exponential minus st cos 5t all over s minus 5 exponential minus st sine 5t all over x all squared. Okay, so let's rewrite everything in this bracket by taking LCM. This becomes integral of cos 5t exponential minus st dt. Of course, the LCM here is s squared. This one can also be written as 1 all over 1. So LCM between the two is s squared. You put it down, x all squared. X squared divided by 1 is s squared. S squared multiplied by 1 still gives us s all squared. Plus same thing, s squared divides s squared is 1. 1 times 25 gives us 25. And this is equal to minus exponential minus st cos 5t all over s minus 5 exponential minus st sine 5t all over s all squared. All right, so we have this. Now, in order to find this integral, it means we have to divide through by what? This term in the brackets. Okay, so we can do that over here. All right, so the integral of cos 5t exponential minus st dt is now equal to, so guys, if I divide both sides by this, the order will change a bit. On this other side, x squared will come up and x squared plus 25 will come down. So I'll simply have x squared all over x squared plus 25 multiplying the whole of this here after division. This will be minus exponential minus st cos 5t all over s minus 5 exponential minus st sine 5t all over x squared. So I have this. So our next target now is to expand this bracket with every term here. We have integral of cos 5t exponential minus st dt to be equal to, of course, this times this first. X here cancels one of the s squared here, so I'm left with just one x multiplying the whole of this value here. This becomes minus s exponential minus st cos 5t all over. At the denominator now, I have x squared plus 25. Okay, minus the same thing now. This multiplying this, x squared cancels this s squared. So I simply have 5 exponential minus st sine 5t all over. At the denominator now, I'm left with what? X squared plus 25. Now, this is the integration or the Laplace of the function we're looking for. But we need to what? Append what? This limit from 0 to what? Alpha, or from 0 to infinity. So appending the limit from 0 to infinity, it means we have to integrate between that limit as well from 0 to infinity. Okay. So to append the limits, this is equal to, let's start with the upper limits first. This is now equal to, so in place of t, we have to append the upper limit. Upper limit is infinity. So wherever you see t, you put in the value as infinity. This is minus s exponential. I have minus st. In place of t, there becomes minus infinity times s. Okay. Cos, in place of 5t becomes infinity times 5. Okay, cos infinity times 5 all over x squared plus 25 minus, same thing here, this is 5 exponential, in place of t here, this is st, in place of that t, it becomes minus infinity times s sine 5t, in place of t is infinity times 5 all over x squared plus 25. That's the upper limit. So usually it's upper limit minus lower limit. So minus, we put in the lower limit now, same thing. This is minus s. You have minus s exponential. This is st, and now lower limit is 0. So in place of t, there becomes 0. 0 times s is 0. 0 times minus remains 0. So this is actually exponential 0 cos 5t. T is 0. 5 times 0 becomes 0. It becomes cos 0 all over x squared plus 25 minus, same thing, this other side, you have 5 exponential In place of st, t is now 0. 0 times x is 0. And 0 times minus is also what? 0. So you have sine 5t, t is 0. So it becomes sine 0 all over x squared plus 25. You have this. Okay. All right. So integral of cos 5t exponential minus st dt from 0 to infinity is now equal to, now exponential to infinity is undefined, same thing as cos to infinity undefined, same thing over here, sine to infinity and exponential to infinity, they are all undefined. So we simply consider them to be 0, consider the whole of this to be 0. So this is off. So I'll simply have all that to give me 0. Remember there's minus here, so minus. Let's move over here now. Exponential 0 is 1, cos 0 is also 1. So I have 1 multiplied by minus s. That will give us minus s all over x squared plus 25 plus, minus. Over here now, I have exponential 0 is 1, but sine 0 is 0, so automatically everything here becomes 0. So this is actually this minus 0. Okay, so integral from 0 to infinity of cos 5t exponential minus st dt is now equal to, this is now 0 minus minus x over. So minus minus becomes what? Plus. So I'm left with s all over x squared plus 25. Hence, this implies that Laplace of cos 5t is equal to what? S all over x squared plus what? 25. That means this was actually what? S all over x squared plus, since the constant is 5 and we have 25 there, so it simply means what? 5 all squared. Hence, the Laplace transformation of a cosine function cos 80 is simply equal to what? S all over x squared plus a all squared. It's as simple as this. So this is the fourth value or table of standard value which you need to know. The Laplace of a constant, a cosine function, is simply what? S divided by x squared plus the constant attached to the cosine function all squared. It's as simple as this. So if you're asked to find Laplace of cos 3t, is simple, it becomes what? S all over x squared plus 3 all squared, which is equal to s all over x squared plus 9. So you need to always know this table of standard values, because when we proceed with solving differential equations using Laplace transformation, then we have to be knowing all of this, because you're not expected to be solving all of this. You can just recall from table of standard values, Laplace of cos 3t is simply equal to this. You can recall and then you solve with the solutions like that. All right. Also, if you're asked to find Laplace of cos 10t, is simple, it becomes what? S all over x squared plus 10 all squared, which is simply what? S over x squared plus 100. All right, so that's the fourth table of constant value. The fifth is the Laplace of sine functions. Okay, the fifth is the Laplace of sine functions. Let's do that and see how it looks like. Alright guys, so as earlier said, the fifth table of standard values is the Laplace of sine functions. So let's say we are given f of t is equal to sine 80. Now I am solving with a without a real constant like we did in the previous video. I'm not using a number for a, but a is of course a constant value, so you should have a number. So let's say we are to find Laplace of sine 80. Again, Laplace of sine 80 is simply equal to integral from 0 to infinity. In place of the function f of t now is sine 80. So we have sine 80 exponential minus st multiplied by dt. So this is now the product of two functions under integration, which means we are going to be employing integration by part formula, which is integral of u dv is equal to uv minus integral of v du. So always remember u is a given function, So u is equal to, the function there is sine at, and the v becomes now the Laplace function, which is now exponential minus st dt always. Okay, so to find the u, we've already explained all of this. The u is simply equal to what? Differentiating sine 80. First of all, you differentiate the angle 80, you're going to have a. Use this to multiply derivative of sine. Differentiate sine, you have cos. Put back your angle 80. Since I differentiated u with respect to t, you simply append the t over here. And v itself is what? The integral of this function. We've done this earlier and we obtained, okay, simply integral of the v, which is integral of this function, and we obtain minus exponential minus st all over s for our v. So plugging this into this equation, we are going to find integral of u dv to be equal to, so the formula says u times v, and u is sine 80, v is equal to this. So we simply have sine 80 multiplying by v, which is minus exponential minus st all over s, minus integral of v du, and v remains minus exponential minus st over s times du. Du gave us a cos 80 dt, so we have a cos 80 times dt. So integral of u dv is now equal to, so rearranging this a bit, we have minus exponential minus st sine 80 all over s. Once more, minus times minus here is plus, so I'll have plus. A is a constant all over x here, s is also a constant, we can pull it out. So we'll have a all over s integral. Rearranging this, we have cos 80 exponential minus st times dt. So this simply means we need to also integrate this part, integral of cos 80 exponential minus st dt. We also need to integrate this by parts, okay, using the product integration. So I'm going to be doing this directly over this side of the board. I'll be doing that integral directly, but of course these procedures or these steps can also be used to integrate this personally. So integral of u dv is now equal to, we obtained minus exponential minus st sine 80 all over s, okay, plus a all over s. So if we carry out that integral, remember u remains cos 80, and then this remains dv, exponential minus st dt remains dv. From the formula uv, so we have u, which is now cos 80 times v. V means integrating dv, which will obtain the as minus s exponential minus st all over s, so times minus exponential minus st all over s, minus integral of v du. V once more is minus exponential minus st over s times du. Now if u is cos 80, then du is simply what? Minus a sine 80 dt. This gives us du. So integral of u dv is equal to minus exponential minus st sine 80 all over s plus a all over s into, okay, rearranging this, we have minus exponential minus st cos 80 all over s. Once more, now this is minus times minus inside here becomes plus. A and s here are constant, we can pull them out, so we have a all over s integral of sine 80 exponential minus st multiplied by dt. We have this. So integral of u dv is equal to minus exponential minus st sine 80 all over s. So let's expand this bracket now with a over s. So a over s multiplied this gives us, remember there's a minus sign there, so we'll have minus a exponential minus st cos at all over s times s here gives us s squared. Same thing here. A over s multiply everything here becomes minus a times a is a squared all over s times s is s squared integral sine at exponential minus st multiplied by dt. All right, now let's put in all symbols and notations. This is integral. What is u and dv? We said let u be sine at, let dv be exponential minus st dt. So append them here. In place of u, we have sine at. In place of dv, we have exponential minus st dt. And this is equal to the whole of this result minus exponential minus st sine at all over s minus a exponential minus st cos at all over x squared minus a squared over x squared integral of sine at exponential minus st dt. So comparing these two equations now, notice that this value in the right hand side is equal to this value at the left hand side. So what do you do? And this is what we're looking for. Integral of sine at exponential minus st dt is actually what we're looking for. Hence, we simply collect like terms. Simply collect them. See if they look alike, bring them together. So I have sine, integral of sine at exponential minus st dt. If negative sign cross an equal to sign, it becomes positive. So this is now plus a squared over s squared integral of sine at exponential minus st dt. And the whole of this is equal to this result, which is now minus exponential minus st sine at all over s minus a exponential minus st cos at all over x all squared. So since one of these integrals can factor, since one of them is common, we can factor it. So we have integral of sine at exponential minus st dt common between 1 plus a squared all over x squared, and this is equal to minus exponential minus st sine at all over s minus this is a exponential minus st cos at all over s all squared. So we have this. All right, so just like we did previously, we are going to now rearrange these terms in the brackets. And of course, if we do that, we have integral of sine at exponential minus st, okay, dt into, rearranging that will give us x squared plus a squared all over s squared. We've already done this earlier, and this is equal to the result. So we have minus exponential minus st sine at all over s minus a exponential minus st cos at all over s all squared. Okay, so in order to make sine at exponential minus st dt subject, we have to divide both sides by what? This term in the bracket. And I explained earlier that if we divide through by this term in the bracket, the order will change a little bit on the other side. So we are going to have integral of sine at exponential minus st dt to now be equal to, so this goes up, I have x squared all over x squared plus a squared, okay, multiplying all through by minus exponential minus st sine at all over s minus a exponential minus st cos at all over s all squared. All right, so we have this. So the integral we're looking for now, integral of sine at exponential minus st dt is now equal to, we simply expand the brackets using these terms. Now, expanding with this s cancels one of this s squared. So I'm left with just one here, multiplying this term. It becomes minus s exponential minus st sine at all over, whereas our denominator I'm left with s squared plus a squared, okay, minus same thing. This multiplies this term now. X squared there cancels this s squared, so I'm simply left with a exponential minus st cos at all over x squared plus a squared at the denominator. At this juncture, we simply append what the limit from 0 to infinity. So appending the limit from 0 to infinity, okay, we append the limit from 0 to infinity. Now, appending that limit, let's start with the upper limit first. We simply have, putting in the upper limit, wherever we see t now, we'll put in the upper limit. This is minus s exponential, this is minus st, and the upper limit is infinity. You have minus infinity times s, okay, sine at. In place of t, we'll simply put infinity, sine infinity times a, all over x squared plus a squared. This minus a exponential minus st. In place of t, we'll put in, this becomes minus infinity times s, okay. We have their cos at. In place of t, there will have infinity, okay, times t, all over x squared plus a squared. So that's for the upper limit. Now this minus the lower limit. For the lower limit, wherever you see t, you put in 0. Lower limit is 0. So you have minus s exponential. Now this is exponential minus st. T now is 0. 0 times everything here becomes 0. We have exponential 0 sine. Same thing, sine at. T is 0, so it becomes sine 0 all over s squared plus a squared, okay, minus a exponential, also exponential 0 cos 0 all over x squared plus a squared. So we have this. Now this is equal to, the exponential of infinity is undefined, the sine of infinity is also undefined. Automatically this is considered to be 0. Same thing as here, considered to be 0. So all the terms to infinity are considered to be 0. We simply have 0 minus, here we have exponential 0 is 1, sine 0 is 0. That means automatically everything here becomes 0. So you have here 0 minus, same thing here, exponential 0 is 1, cos 0 is 1. 1 times a gives us a all over x squared plus a all squared. Okay, so from here, of course, minus times minus here is plus. This is actually what? A all over x squared plus a squared. Hence, the Laplace transformation of sine at is actually what? A all over x squared plus a squared. So this is how to find the Laplace transformation of a sine function. Simply a, which is a constant, divides s squared plus a squared. Now let's pick a slight example. Alright, so let's say we have to find Laplace of sine 5t. It is simply equal to, remember, a just stands for 5. It becomes 5 all over x squared plus 5 all squared, which is equal to 5 all over x squared plus 25. It's as simple as this. The Laplace of sine 7t is equal to 7 all over x squared plus 7 squared, and this will give us 7 all over x squared plus 49. It continues like that. So that's how you find the Laplace transformation of a sine function. Alright, so in all, from the very first video down to this video, we are given 5 total table of standard values which is used in the Laplace transformation. Now I'm going to be highlighting the 5 which we've solved so far over this other side of the board. Okay. Alright, so the very 5 table of standard values which we've highlighted so far from the very first video includes, the first one is the Laplace transformation of a constant value. So if you have to find the Laplace of a constant a, this is simply what? A all over s. Hence, if you have to find the Laplace of 5, it is simply 5 divided by s. So that's the very first one. Second one is the Laplace of an exponential function, which I talked about in the first video. So let's say you have to find Laplace of exponential at, okay, something like this. This is simply equal to, we said it's going to be 1 all over s minus a, okay? It's going to be 1 all over s minus a. Hence, if you have to find the Laplace of exponential 3t, it is simply equal to 1 all over s minus 3, where 3 remains a constant a. The third is the Laplace transformation of a function raised to a constant or to an integer. Let's say we are given Laplace of t to the power of n. T is the function raised to n, n is an integer. Then this is simply equal to n factorial all over s to the power of n plus 1. Hence, if you have to find the Laplace of t to the power of 3, this is actually 3 factorial all over x to the power of 3 plus 1, and 3 factorial is 6 all over 3 to the s to the power of 3 plus 1 is 4. That becomes the Laplace transformation. Now, in this video, we talked about the fourth one, which is the Laplace of cosine function. And I said if you're given Laplace of cos, you have to find Laplace of cos at, you simply obtain s all over x squared plus a squared. It's as simple as this. So, which means if you have to find the Laplace of cos 3t, it becomes what? It becomes s all over x squared plus, in place of a squared, it becomes 3 squared, and 3 squared is simply what? 9. You have this. And finally, for this video, we are on the fifth. We talked about Laplace transformation of sine function. So if you're given to find Laplace of sine at, we said this is simply going to be what? A all over x squared plus a squared. Hence, if you have to find Laplace of sine 3t, it is simply going to be equal to what? 3 all over x squared plus 3 squared becomes what? 9. You have this. So, for the first and the second video, we've been able to cover 5 tables of standard value for the Laplace transformation. In the third introduction video, which is the next video, we are going to be talking about the remaining 2, and then we can start Laplace transformation proper. Alright guys, I will see you in those videos. Thanks and cheers.